In this example, we need to find solutions to the equation x plus 2 squared minus 3 equals 0. To solve for x here, we have three operations to undo. First, we add 2 to x, then we square it, and finally subtract 3 to get 0. So following Frog and Toad, we will undo these operations in the opposite order. First, we will undo subtracting 3 by adding 3. Then, to undo the squaring, we'll take the square root. And finally, to undo adding 2, we subtract 2. So let's start by adding 3 to both sides. This gives us x plus 2 squared minus 3 plus 3 equals 0 plus 3, which is 3. And on the left, we have x plus 2 squared, since minus 3 plus 3 is 0. Now, we can take the square root of both sides to undo the squaring. This gives us the square root of x plus 2 squared equals the square root of 3. Since we can't simplify the square root of 3 any more than just the square root of 3, that's how we'll leave it. But we can simplify the left-hand side. The square root of x plus 2 squared is the absolute value of x plus 2. If you need to be reminded why this is not just x plus 2, you can click the purple link now. Since the absolute value of x plus 2 equals the square root of 3, we know that x plus 2 has to either be plus or minus the square root of 3. In this, we can solve for x, even though it's messy on the right-hand side, by subtracting 2 from both sides. This will give us x plus 2 minus 2 on the left, which is just x, and minus 2 plus or minus the square root of 3 on the right. And if we want to write these solutions in a list, as WebWork will often ask for, we would write these as x equals negative 2 plus the square root of 3, negative 2 minus the square root of 3. Now let's take a second look at our example. What if we had multiplied out the left-hand side? Then we would write x plus 2 squared minus 3 as x plus 2 times x plus 2 minus 3. Here we need to distribute. X times x is x squared, plus x times 2 is plus 2x, plus another 2x, and finally plus 4. And we still have minus 3 on the end. So multiplying this out, we get x squared plus 2x plus 2x plus 4 minus 3, which can be simplified because 2x plus 2x is 4x, and 4 minus 3 is 1. This leaves us with the equation x squared plus 4x plus 1 equals 0. Hopefully, this should look familiar. Remember, we tried to solve this before with factoring, but we couldn't. So why can we solve it now, but we couldn't before? Well, if we write it as x squared plus 4x plus 1, we can't solve it. But if we write it as x plus 2 squared minus 3, we can solve it. Why? Because on the right, x only shows up in one place, which means that we can undo operations step by step, just like we finished doing. The question becomes, if we are given an equation in the form ax squared plus bx plus c equals 0, like x squared plus 4x plus 1 equals 0, how do we write it in the form a times x minus h squared plus k, like we have above, x plus 2 squared minus 3 equals 0? Because once we write the quadratic in this form, we can solve it. So our next steps are to be able to figure out how can we write it in this form. For clarity, it's worth pointing out that in this example, a equals 1 because we have 1 times x plus 2 squared, h equals negative 2, so that x minus h is x minus negative 2 is x plus 2, and k is negative 3, for minus 3 at the end. We will soon see why having negative h and positive k is useful for us.